Find the value of x. So we have 6 and x and then 9 labeled in the right triangles. So this picture represents there are actually 3 right triangles in one. So the 6 and the x make a right triangle. The x and the 9 make a medium-sized right triangle. And then you have 2 legs, and the hypotenuse is 6 plus 9, which is 15. Now these right triangles, they're all similar. So if I were to separate the triangles, okay, so we have a 9, and then this x is for both of these sides because they're really the same side, just split up now, and then a 6. So the 6 is the shortest side of the smallest right triangle, and the x is the shortest side of the middle-sized right triangle, so 6 to x, because the triangles are similar. And then the x is the second longest side of the small right triangle, and the 9 is the second longest side of the medium-sized right triangle. So it's going to be x to 9. So 6 to x and x to 9. And this is also a geometric mean situation. Notice that you have x and x on one of the main diagonals. So that means this x, this height of the largest right triangle, is the geometric mean between 6 and 9. So let's go ahead and solve for x here. X times x is x squared. 6 times 9 is 54. So x squared equals 54. Take the square root of both sides, so x equals radical 54. We're only using the positive root because x represents the length of a triangle, and you can't have a negative length. So that's why we just have radical 54 and not plus or minus radical 54. So let's simplify this radical 54. Radical 54 is 9 times 6. So x equals radical 9 times radical 6. So x equals, radical 9 reduces to 3, radical 6. So there's your answer. X equals 3 radical 6, which is choice A. So let me just review the process here. We have 3 similar right triangles, which means the side lengths are proportional, which is why I was able to make this proportion. And x turned out to be the geometric mean between this 6 and this 9. So it was very easy to solve.